All right, 3.5 is going to be talking about something called the completing the square. But before we get to that, let's go over square root property first. So the square root property says that for any real number, n, if x squared is equal to n, then what you got to do is you got to take the square root of both sides. So then x is equal to plus or minus, that's the key, and then the square root of n. The key is when you do the square root property, there are two answers that you should be coming away with. Don't forget the second answer. So if you're asked to solve x squared plus 10x plus 25 equals 49 by the square root property, they're telling you that you have a perfect square there. So what we're going to do is we're going to factor this left-hand side. And when you factor that left-hand side, we're looking for two numbers that multiply to get 25 and add to get 10. You're going to find that your parentheses are x plus 5 times x plus 5. But instead of writing x plus 5 twice, we're going to combine them into a single expression and say x plus 5 squared. Now, the square root property says, well, in order to get rid of a square root or a square, we have to take the square root. So I'm going to square root the left and I'm going to square root the right. So the left-hand side just becomes x plus 5. The right-hand side is plus or minus 7. Now I have to solve for x. So what I'm going to do is I'm going to bring the 5 over and put it in front. So it's negative 5 plus or minus 7. Put it in front so that you're actually able to see now when we branch where the numbers need to go. So if it's negative 5 plus or minus 7, then that means it's negative 5 plus 7. And that's negative 5 minus 7. So that gives us two answers. So this is 2 and negative 12. And those are going to be your two answers that you write. Now, should you write them as negative 12 comma 2? Probably, just because that's the way they would appear on a number line. All right, second one of these, same idea. So we're going to factor the left-hand side. And if they're telling you to use the square root property, they're telling you that it's going to be a perfect square. So in this case, we get x minus 4, x minus 4. So that's going to be x minus 4 squared equals 9. Take the square root of both sides. You get x minus 4 equals plus or minus 3. The 4 is going to come over. And again, you put the 4 in front of the value so that when we branch them, you can see what number appears in front and you don't have this plus or minus thing going on. And you get 7 and 1. So we have 1, 7 for our final answers for those. All right, where this now leads us into is something called completing the square. So all quadratic equations can be solved using the square root property by making one side a perfect square. We do this by completing the square. So what we're going to run into with the next set of examples is they're not perfect squares like we had with example 1 and 2. So in order to make them perfect squares, we're going to follow a couple things. So remember, quadratics follow the form ax squared plus bx plus c. So we need to first figure out, you're going to find what half of b is. Okay, then what you're going to do is you're going to square that. Square that. And then what you're going to do is you're going to add to the polynomial. Add that. And we're going to say to both sides. And I'm actually going to say of the equation because we're going to have an equation here. All right, so the issue again that we run into is that when we look at this problem for 3, it's not a perfect square on the left. So what we're going to do first is we're going to move the 8 over. So when we move the 8 to the other side, I now have 24 on the right-hand side. Now, we're going to set up our completing the square process. So we're going to do x squared minus 6x does not change. Plus, leave a blank, equals 24 plus, leave a blank. The reason I'm putting a blank on the left and the right is because if I'm adding a number on one side, I have to add the number on the other side. So this is where our steps come above. So b in this case comes in front of the x, which is negative 6. So half of b is negative 3. And then negative 3 squared would be a positive 9. And that positive 9 is now going here. So we are adding 9 to both sides. And now what you are going to find is the left side is a perfect square. X minus 3 times x minus 3, which is x minus 3 squared, equals 33. And now we can go with the square root property in order to simplify. But you need that at first initial step. So I'm going to take the square root of both sides. I get x minus 3 equals plus or minus radical 33. Then I'm going to add 3 to both sides. Again, the number goes in front. And again, for these, you can split them up, but because you have the square root and you can't do anything else with it, you can just leave them together and write 3